Hello and good evening, CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course, and this evening's video tutorial is going to be on Lab 5-1, where we're going to configure and verify path control using policy-based routing, or just simply PBR. As usual, I've already configured all of the IP addressing. You can see here on the right-hand side, this is the diagram we'll be working with. There's been a couple changes. I've used fast Ethernet interfaces here, just simply because it's easier to cable up, and there's going to be no change in the lab, no value in using serial interfaces. So the fast Ethernet interfaces will be just fine. And we have a single Ethernet or serial interface here between router 3 and router 4. So I'm actually going to pick up right at step 3, configure basic EIGRP. So we're going to implement EIGRP Autonomous System 1 over all of the interfaces that we've configured. So on router 1, excuse me, on router 1, let's go ahead and dive in. We're going to go from user exec to privilege exec and then into global config. And we're going to spice this up a little bit, right? We've already seen the router EIGRP with the autonomous system number. Let's go ahead and use named mode here. So we'll say CCNP, because that's what you guys are going to be at some point here after we finish this course and you pass your exams. So router EIGRP CCNP, and we're going to say address family IPv4 unicast autonomous system 1. Now it wants us to, if I say do show IP interface brief, you can see we've got two 172 addresses and we have a 192.168.1 address. So since I'm entering it, or I'm enabling EIGRP on all interfaces on the router, what I'm going to go ahead and say here is AF interface default, and let's passive all of the other interfaces on the router. And I'm assuming, it doesn't look like it calls for the passive interface of the loopback address, but that's definitely something that we would want to do. So I'll go ahead and exit out of AF interface default mode, and we're going to go ahead and say, and actually I apologize, let me get back in there, AF interface default, and we're going to say no passive interface FA00, no passive interface. Or did I not go back into? Oh yeah, we're gonna fix it like this. So we'll say no passive interface, and let me see where I'm at here. Oh, okay. So we'll say AF interface FA00, no passive interface. We'll exit back out AF interface FA01, and we're going to say no passive interface, and then we'll exit out of there, and we'll say interface, and we'll leave. Actually, we're going to leave the loopback interface passive. So FA00 and 01 are not. So let's go ahead and let's activate things here. I could use 3 distinct statements, or I could just say network 0.0.0.0 and actually activate EIGRP on every interface. And we'll do that for this setup here. So this is what our EIGRP config looks like right now. We've got the address family mode in full play here. And you can see AF interface default is passive interface. We've got no passive interface on fast Ethernet 00 as well as 01. And we've got our network statement enabling EIGRP on all interfaces. If I said do show IP EIGRP interfaces, and let's fix EIGRP here, you can see that we're actually running EIGRP on those 2 interfaces, but we've got the loopback passive. So do show IP protocols should show us, where are we at here? So we've got the router ID, the maximum paths, and it is not showing me do show IP EIGRP, drawn a blank here, and that is not what I'm looking for. And am I looking right by it? Because I don't see the passive interface listing for, and it may be because it's name mode. And so we'll see here, because this is 15.1 code. I'm going to see what happens on 15.3 code. So that takes care of router R1. So let's come over here to router R2, and we'll do much of the same thing. We'll avoid the passive setup. So we'll go from user exec to privilege exec into global config. I'll say router EIGRP, and here we'll just use 1. So if I say passive interface default, I would have to say no passive interface FA00, no passive interface FA01, and we'll leave the loopback address passive, and then literally just put a network statement for all interfaces. So do show IP interface brief. You can see we've already got the adjacency up. Do show IP EIGRP interfaces. And you can see we've got our two interfaces listed there. Do show IP protocols. And let me see. I've got to be thinking of another command. Unless I just am not seeing it here, where it will typically list the passive interfaces. Do show IP EIGRP neighbors detail? Was that it? No, that is not it. Yeah, I'm going to have to think about this for a second. I'm drawing a complete blank here. So we'll continue on. Excuse me. So we've got our adjacency up between router 2 and router 1. Now let's go ahead and go to router 3. And we're going to do the exact same thing. We're going to go from user exec to privilege exec into global config, router, EIGRP, and over here we'll say CCNP, address family IPv4 unicast, autonomous system 1, and we won't do the passive interface here. We'll just simply say network 0.0.0.0. Right now we should see an adjacency between 1 and 3 and 2 and 3, and there they are. So do show IP EIGRP neighbors. So there are the two neighbors, and I'm going to actually stretch this out. We're going to lose a little bit in the diagram, but that's okay. We're going to gain quite a bit here in our output. There we go. Makes it a lot easier to look at the output when it's not wrapping on the screen. So the neighbor relationships are up, and then finally we've got router 4, where we're going to go from user exec to privilege exec into global config, say router EIGRP 1. And I'll just simply go ahead and say network 0.0.0.0, and let me make sure here. Hold on. Actually, they only want it for the 192.168.4.0, so they don't have it in there. So let me do this. I'll go ahead and shorten it here. So I'll say network 192.168.4.0, and then 0.0.0.127, and then we're going to say network 172.16.34.0, 0.0.0.7, because that's a /29. And there we go. We have an adjacency up between router 3 and 4. So do show IP route over here on router 4. And you can see I'm learning quite a few EIGRP routes. And I'm learning them all from router 3. So we've validated neighbor connectivity already. We saw the messages come up and it said, did you receive the output you expected? And yes, we did. Then it had a ping script. We're going to go ahead and forego the ping script and go to step number 5, verify the current path. So on router 1, if I were to say, let's end out of here, show IP route, include or begin gateway. And you can see gateway of last resort is not set, but we're able to see that we have all of our routes here on router 1. So now we're going to trace, because again, when we take a look at this, we're talking about policy-based routing, right? And remember that policy-based routing is static. It is not dynamic. So what we're looking for here is we want to see from router 4, how do I get to loopback 1 over here on router 1? How is this going to work coming from router 4? So let's give it a try here. Let's clear this, or actually we're going to have to clear the screen there. All right, and we're going to say clear the screen. Okay, so from router 4's perspective, if I were to say trace to 192.168.1.1, let's see what path it takes. Does it shoot northbound to the 172.16.23, or does it continue straight across on the 172.16.12.0/29 network? So let's see what happens here. And I actually should change the sourcing on this. So the first hop is over to the 34.3, which is the exit point out, and then it takes the 13.1. So let me change this. They wanted me to source this from the 192.168.4.1, and I don't believe we're going to get any different result, but let's see here, because it should be taking the 23.2 path. And so we'll give it a second here to finish up. So there's our first hop, which is router 3. And then from router 3, we go to 13.1. And then we finish. Now the output that's being shown, so it was asking for some bandwidth to be set, and I think I went right past that. So let me go back up here. Let me double check this, because they wanted, it says the bandwidth was set. I don't remember. And it was in, okay, perfect. So router 4 to router 3. So 3 to 2. So let me make a couple changes here. So on router 3, what I'm going to do is I'm going to go to interface FA01, and I'm going to say bandwidth 128. And then I'm going to go into FA00, and I'm going to say bandwidth 64. And let me make sure that that is correct. Yes, that is correct. All right, and let me make sure those are the only changes. So on router 3, so then router 2, it has bandwidth 128 on both interfaces. So let's make that change. Interface FA00, bandwidth 128. Interface FA01, bandwidth 128. And finally, router 1, we're going to sneak over to router 1 here. And we're going to say, go into global config interface FA00, and that's going to be bandwidth 128, and interface FA01, bandwidth of 64. All right, now let's come back over here to router 4, and let's rerun this trace route, because what we should see now is that EIGRP should have made the changes so that the preferred path is going to be the northbound path based off of the bandwidth setting. So we should see our second hop. The first hop is always going to be the same for router 4, because that's the only way out is router 3. Now we should go to the 172.16.23.2, and there we go. And that's what we're looking for. So now we should take a 172.16.12.1. There we go. And then we reach our destination. Okay, I apologize there. I had gone right past those bandwidth statements, and as soon as it showed the traceroute output, it was clear that that was not what was expected. So it says, notice that the path taken for the packets sourced from the R4 LAN are going R3, R2, R1. It says, why are the R4 interfaces not using the R3 to R1 path? Well, it's because the bandwidth has been changed in our setup. So on router 3, it wants us to do a show IP route. So we're going to say show IP route. And note that the preferred route from R3 to R1, which is the 192.168.1.0 network right here, this EIGRP learned route, here is the successor for the successor route, right? So we're talking about going this way. So the traffic now from router 4 is flowing this direction, then from 2 down to 1, and then to the loop back. Okay? So that is how the traffic is flowing right now. And the reason that we're covering this is because we're going to be doing some policy-based routing where we're going to be forcing, based off the source information, how the traffic is actually being routed. All right, so confirm R3 has a valid route to reach R1. So let's do a show IP EIGRP topology 192.168.1.0. And as you can see, there's no doubt that router 3 has a valid path. And here's our computed distance, or the metric, as you can see, quite a big number because we are using the named mode. And the number down here is also just as large, except you can see we've got 10 billion? 10 billion as opposed to 5 billion. So that is our best cost path, right? And is this a feasible successor? It definitely is at 327 million. So if I were to say, let's clear the screen here. If I were to say show IP EIGRP topology, we should see two routes for the 192.168.1.0/24. We have the successor always listed first, and then our feasible successor, because the reported distance of, and this is router 1, the reported distance of router 1 to reach that network is less than the current successor's feasible distance. And again, the feasible distance here is 5.46 billion, and the reported distance here is 327 million. Yes, the days of RIP are long behind us when we looked at hop count. All right. So clearly a feasible successor. That's what the topology table looks like. So the answer to the question, does R3 have a route? It certainly does. It has a feasible successor. So R4 has two paths that it can take. But the metric going northbound is less. So now here we go. Step number 6, we're going to configure policy-based routing to provide path control. And as you can see, remember, we're currently going northbound, and that is what we're going to manipulate. So here's what we're going to do. We're simply going to grab all traffic from the 192.168.4.128 network. So we're going to be sourcing things from that loopback 5 address. So on router 3, right, this is where I'm going to capture the source traffic and then manipulate the next hop. So how do we do that? Well, the first thing is we need an access list. So IP access list extended, and I'm just simply going to call this PBR, right? So the first thing I'm going to do is, if I do a question mark, you can see I can put a remark in here. So I'll say PBR to redirect traffic for the 192.168.4.128/25 net. So our remark is in there. Now we want to match that traffic. So it's going to be permit IP host. Well, actually, we're doing the whole subnet here. So permit 192.168.4.128, and then we'll get our wildcard mask in here for a 120 for /25, I should say. So permit 192.168.4. Whoops. Let me pull that back. So permit IP, yeah, we want IP, yeah, there we go. 192.168, sorry, I keep mistyping that. 192.168.4, let's make sure we get it correct here, .128, and then the wildcard mask 0.0.0.127, and so from that network going anywhere, that's what we're going to match. All right, now I'm going to go ahead and exit out. So we've defined what traffic we want to capture. We've created the ACL. So if I say do show access list PBR, we have the access list right there that's going to match the traffic. Now we need a route map to go ahead and apply to the interface. So let's go ahead and say route map, and I'll just simply call this PBR, or let's say RM_PBR. And we're going to permit 10, and I'm going to match IP address. Now be careful here. Remember that if it's a prefix list, I would say prefix list and then the name of the prefix list, but it's not. It's a named ACL. So this is where I put the word, right? So and that's the name of the named ACL. So just PBR in this case. So we've got match IP address PBR, and then what are we going to do? We're going to set the next hop, set IP next hop, sorry about that, set IP next hop to 172.16.13 .1. And remember, that is router 1. So now let's take a look at our route map. Do show route map rm underscore PBR. So there's our route map. We have a single ACL that we're referencing. It's PBR. And you can see we have no matches right now because we haven't applied it to the interface. So here's what we're going to do on our serial interface, serial 010. Now we're going to go ahead, we're going to jump in here, and we're going to say IP policy route map, and then simply the name of my route map, which is rm underscore PBR. And that's it. So again, you figure out where you want to change the routing, you go about it in a source-based fashion, and then we create the ACL to make the match, we create the route map referencing the ACL, and then we apply the route map to the interface. All right, so we already took a look at the route map, so now we're going to go ahead, we're going to test, and let's see what things look like here. And give me 1 second, I'm trying to see. Oh, they're asking, okay, I see. So they want us to create, because the debug IP policy output could be a little much. So let's see debug IP policy, and let's see what we've got going on here. They want us to create an access list, and this is not a bad idea. In a production environment, this is actually highly desirable. So let's go ahead and let's not fight it. We'll go ahead and I'll say you all, or do you all. So do undebug all. And then we're going to go ahead and say access list 1 permit 192.168.4.0, and we're just going to grab that entire /24 because we're going to get both networks. And there we go. So now when I say debug IP policy, I can reference the ACL, and the debug is only going to show me the information for the traffic that I'm matching, which is basically the 192.168.4.0. We're not going to see everything else. So now let's test the policy. So the first test is going to be for the traffic that we did not manipulate. Remember, PBR is static and it's source based. So when I say source 192.168.4.1, way over here on the right, that traffic is not being matched in an ACL. So we'll leave that traffic red. That traffic should come here, shoot to here, and then shoot down here. Am I matching? No, I'm matching the 128. And then come down to router 1. The traffic that we changed, and we'll switch that to green, the traffic I changed was loopback 5. And loopback 5 is going to source from the 192.168.4.129. It's going to come here, and then it's going to continue straight across. And this is where we see the effects of PBR. We're routing based off of the source IP. So when the traffic hits this interface right here, it's going to look at traffic source from loopback 4 and say, nope, go ahead, you go that way. It's going to look at traffic sourced from loopback 5 and say, aha, I have an ACL that is matching you. And my interface has a IP policy referring to a route map that references an ACL that matches loopback 5's subnet. That traffic will be policy routed based off the source IP and sent this direction. All right, so let's check it out. Let's see what we've got here, and hopefully this is going to work flawlessly. All right, so we're debugging on router 3. However, it's over on router 4 where we're going to say trace route to the 192.168.1.1. Now, this is critical. If I didn't source it from the loopbacks, what would the source address be? And let's talk about that for a second. So I initiate the trace route here, going to the 192.168.1.1. If I don't say source loopback 4 or source loopback 5, what is the source IP going to be? Exactly. It's going to be 172.16.34.4. It's going to be the outgoing interface because by default, that will be the outgoing interface. And so that would be the source IP address. And let's confirm that. I'm going to go ahead and we'll leave that there. I'm going to go ahead and we're going to not say source. We're going to let this run. And let's see what router 3 is going to report since it's doing the debug. Now it shouldn't report anything, correct? And you would be right. Because what is our debug IP policy? What is it matching? It's only matching traffic from the 192.168.4.0/24, which includes both loopback 4 and 5. So we're not seeing anything here. So what that tells me is it's not matching either of those, or I should say either of those networks or the ACL. And which way do we go? We go exactly the way that we thought we would because the traffic is not being policy routed. So if I were to, let's go ahead and say you all, and then just say debug IP policy, and I'll put it back on with the access list in a second, and let's run this again. Let's see if it says policy routed or normal forwarding, and take a look at that right there. All of the packets are not being policy routed. They are being forwarded normally, right? And you can see that output right here. And as the screen continues to slide. And so you can see, right, it's all being normally forwarded, okay? So it's not being policy routed. So let me clear the screen. And as you can see, we're receiving all kinds of other traffic here, destination to the all 255s, some to 192.168.1.1. But again, the source is 172.16.34.4. Okay? And so that's the difference, is that it's not matching the policy that we have. So let's go ahead, say you all, let's rerun that debug IP policy 1, and now let's come back to router 4 and let's source it first off from the 192.168.4.1. And so what this is going to show is, remember, our access list is not interested in 4.1. It's interested in 4.129, or the subnet 128/25. So let's see over here. We should see this turn blue, and there we go. When you see that little thing turn blue in Secure CRT, it means we've got some activity. And so here we go. So we're running our trace route. We've got the source IP. So this proves that when we source that trace route, that it changes the source IP in the packet. So 192.168.4.1. The destination is 192.168.1.1 because that was the trace route we ran. Now take a look, and it says FIB, forward information base policy rejected, no match, because it didn't match any of the traffic that the IP policy route map references in the ACL. So as a result, we get normal forwarding. Okay? All right, so that is what happens when we're getting normal forwarding. So what if, for whatever reason, put me some space here between those guys, if we did end up with it being policy routed. So we're going to change our source, and actually there was a question here. It says, why is the traffic not using the R3 to R1 path as specified in the R3 to R1 policy? So it doesn't take the specified path, again, because LAN A, or loopback 4, is not meeting the criteria that's in the ACL that the route map identified with the IP policy route map statement on serial 010 on router 3 is matching. But it is matching 192.168.4.129, and let's see that here in action. And we'll come over here on router 3 and watch the debug live as we see what exactly is being matched. And take a look at that. So what do we have here? Well, The source of the packet, right? This proves again that by putting in that trace and then putting the source in there, we change the source IP in the packet to 129. Our destination is 192.168.1.1, fib policy match, and then fib policy routed, right? So it got policy routed because it matched the criteria that we had laid out. And actually, it looks like we are experiencing some issues here. 192.168.1.1, 192.168.4, 129. And how is that Control-Shift-6? Let me take a quick look here. Show IP route. So the 192.168.1.1, we go to 34.3. Let's check here. Let's say show IP route EIGRP. And so it shows 23.2, but it's policy routed over to router 1. So how is it possible that it's not even getting to the first hop? So this is interesting here. Let's see. Show sorry, not router 2. I want to see router 1. Show, oops. So we'll say go to privilege exec, show IP route EIGRP. And to get back to the 192.168.4, aha. So it looks as if router 1 has a route to the first network, but not to, let me check here. Let's say show run section EIGRP. And that is correct that the second network, and I wonder if that is a mistake. Yeah, so back in the setup, they had asked us to only configure loopback 4 on router 4. And let me see here. Let me look at a show IP route. Yeah, so that's interesting. Okay, so back on step 5, it says verify the current path. On router 1, it shows it's learning an EIGRP route for the 192.168.4.128 network. However, on the setup for this activity, they do not have us activate EIGRP on. Or I see what they did. Okay, they put in a classful statement. So this is definitely my bad. So we'll go to global config. We'll fix this right now. We're going to go to global config router EIGRP 1. We're going to say no network. So my mistake. I put in the network statement there and the wildcard mask and did not stick the other wildcard mask in. So now if I come over to router 1, what we should see is that we have a route here for the 192.168.4.0, and these are in numerical order, so we'll give it a second here. Waiting for it to propagate. And let's make sure that we've got that right. And it did not take that. Oh, I see what happened here. Hold on, router EIGRP1. Yes, it's back to that fortuitous failure, 192.168.4.0, allowing me to get some extra troubleshooting in here. I put no network, and it should have come up almost instantaneously over here, which it now does. Here is my route. So now that router 3 actually knows what to do with this policy-based traffic, let's kick that ping back off and let's source it from the 192.168.4.129 which we're still debugging here on router 3, so we should see some activity here on router 3, and we do. And what we should see over here is not the 3 asterisks. There we go, because we've got the routing information in there now. So 172.16.34.3. My second hop should be the 172.16.13.1, and then I should reach my destination. Right? So the traffic coming from loopback, sourced from loopback 5. And what this shows is this really shows that we are doing policy-based routing, but more importantly, we're doing source-based routing. Because take a look here. The source is 192.168.4.129. The destination is the destination we were trying to get to, 192.168.1.1. And take a look here. Fib policy routed. Right? So we got the match. Now, there's also some other commands that we can run to see what matches we're getting. So if I were to say show route map rm underscore PBR, you'll see down here at the bottom where we've got 28 packets and 896 bytes. If I jump back over here to router 4, let's check and see. I'll kick the trace off again, and I leave these circles there because I'm anticipating that those numbers are going to change as soon as the debug kicks off here. There we go. So now it's 29 and 928. And then we've got some more information there. Now it's 32 and 1024. So as you can see, policy routing matches, we're having success here. And again, 2 ways you can check your success. The ultimate way is to actually do that trace route to make sure that the traffic is transiting the path that you wish it to take. Now, remember we said that PBR, and this is how we're going to wrap this activity up, we said that PBR is a static-based routing method, right? That it's not dynamic. And PBR is great with static routes, okay? Because static routes, just like PBR, are static. So if my, one of my hops were to go away, PBR is not smart enough to figure out I need to reroute the traffic. Well, if that's the case, let's do a little test here. So this is router 3, and this FA01 here, this is the next hop. This address right here, 172.16.3.1, that's the next hop for the policy-based traffic that is being matched here on router 3. So I'm going to take down on router 1, let me double check that, FA01. So if I go into global config and say interface, fast Ethernet 01, and I say shut, the interface is going to go down. Now on router 4, if I'm pinging 192.168.1.1, and I'm sourcing the ping from 192.168.4.129, the pings are working. So how is that possible? Because all of the traffic, let's kick off another trace route here even. If I do a trace, is the trace working? And we'll give it a second here to go ahead and remember, we still sourced it from the 192.168.4.129. And what do we see here that is very, very interesting? So what's the output look like? Well, we get to the 172.16.34, but now the traffic is automatically routed up to router 2 and then down to router 1, basically doing what it would have done if it wasn't being policy routed. And so here's the problem. When we look at the output that we have here, you can see the IP packet sourced from 192.168.4.129 with the destination going to 192.168.1.1. It says normal forwarding fib policy rejected. Now it's not rejected because it wasn't a match. It was definitely a match. And we're going to take a look at the route map here in a second showing that this was a match. But here's the problem. The Ceph IP policy the forward information base for the next hop is not attached. The next hop was rejected, and iOS, because we're using a dynamic routing protocol, is smart enough to figure that out and say, nope. And in fact, here's your proof right here, fib policy match. So we get the fib policy match, PBR counted, then we see that the fib is not attached, right? The forward information base for the next hop is not attached. There's no entry because the interface has been shut down. It gets rejected, and then it gets forwarded normally. And again, this is because we're using a dynamic routing protocol, that this is auto-magically happening for us. We did another scenario in one of the discovery activities where there was not a dynamic routing protocol. And the hop, or the next hop that we were trying to get to, we shut down that interface, and we saw that policy-based routing, when you're dealing with static routes where there's no dynamic routing protocol to kind of bail you out here like this, that what ends up happening is the traffic just simply black holes. So let's clear the screen. Let's see, do we lose any packets? So here on router 4, I'm going to kick off a ping, and I'm going to say repeat. We're going to put a big number in here. And we're just going to go ahead and let this go. And you can see it doesn't seem to be going super fast, right? So over here on router 1, let me go ahead and say no shut. So we're going to bring the router 1 interface back up. Does it increase the speed with which these packets, and you see we dropped one packet there, and there's really no increase in the speed, right? It's still just kind of chugging along. So let's give it a few more seconds. And again, that's pretty quick, right? We've got basically a single drop there, and then the traffic continues to flow. So if I come back to router 1, the adjacency is already up here. I'm going to say shut. Let's see how many packets we drop until things get sorted out. So 3, 4, and then 5, and then things come back online. But again, the reason this is happening is because of EIGRP. And we saw, again, in the discovery activity, we saw where when there is no dynamic routing protocol, PBR will literally choke and black hole the traffic. It'll go to the bit bucket. All right, well, this wraps up Lab 5-1 from the Networking Academy curriculum. Hopefully this has given you a little more exposure to policy-based routing, how powerful it is. And remember, it's static by nature, and it is source-based routing, as opposed to the traditional destination-based routing that iOS normally uses. All right, thanks for watching, and I'll see you guys on Monday.